Hi everyone, this is the video showing examples for the tutorial on integration of trigo functions. Before we proceed to tutorial, let's look at some basic formula that we need to know. To differentiate, we know to differentiate the sine ax, if you get the a cos ax, meaning that if because differentiation and integration, they are reverse operation. Meaning that if you integrate cos ax, you will get back your sine. And a, when you integrate both sides, and a you move to the other side, you get 1 over a. You can remember like this. When you differentiate, you're going to multiply by your by the coefficient of x. When you integrate, you're going to divide the answer by the coefficient of the x. So this is the first formula that we have. And the second one is differentiating the cos ax, you have a negative a sine ax. So remember there is a negative sign here. When I integrate the sine, I'm having here, integrate sine, I have to move the negative a to the other side. I got my negative 1 over a. Negative 1 over a of the cos ax. Because we differentiate cos, we got sine. Integrate sine, we definitely will get back the cos. And remember to divide by a, and because of the differentiating the cos, you get the negative, meaning that integrate sine, you get a cos. And the third formula is differentiating tangent ax, you have a secant square ax. And integrating secant square ax, okay, reverse operation. We are going to move the a to the other side. We have 1 over a. And the answer is a tangent ax plus constant c. Alright, so this is the three formula you need to know before we proceed to the question. Now we proceed to the few examples. There are three more formulas that you need to know. There is a differentiate the cotangent ax. You got negative a cosecant square ax. Meaning that when you integrate cosecant square ax, you will get negative 1 over a cotangent ax. Alright? Then for the secant, you will differentiate secant ax, you get a tangent ax, secant ax, tangent ax. Then meaning that if you come to integration, integrate secant ax, secant ax, tangent ax, you get 1 over a secant ax. For the last formula, there is integrating cosecant ax, cotangent ax. You get the negative 1 over a cosecant ax. So you got to remember those 6 formula. When you come to these 6 functions, you must know there are formulas to integrate. You do not have to use substitution method or whatever technique. Just use this formula to integrate. Alright. Here I have 6 examples on integrating this trigo function using those 6 formulas. Now we proceed to the question A. Integrating sine 2 minus 3x, you can apply the formula and integrate directly. Integrate sine, we know we get cos 2 minus 3x. And then your doubt, is there any negative in front of the cos or not? You just ask yourself, differentiating cos, do you have some negative sign? Yes. If yes, meaning that when you integrate sine, you get back your negative cos. For this pair, there is a negative between them. So meaning that when you differentiate, you have negative. Integrate, you also will have a negative. Alright, the negative won't disappear. The negative still will be there for that pair of, when you differentiate cos, you get negative sine. Integrate sine, you get back your negative cos. And don't forget to divide by your answer by by a coefficient of the x. Coefficient of the x is negative 3. Okay, which is according to the formula, this is your a. Alright, and then this is an indefinite integral. Of course, you need to plus constant c. And the final answer, you might simplify it, writing 1 over 3, because negative divided by negative, you get positive, and multiply by cos 2 minus 3x plus c. Okay, this is the answer for the A. And for the b, you need to integrate cos 2x minus 6 dx with respect to x. So integrate cos, you get your sine. And the next step, I'm going to check the negative, the sine, is it, I need to put negative here. I will check back. I differentiate sine, I got positive cos. Meaning that, then I need to divide my answer, my sine, by 2, because this is your a, according to the formula. This is your a divided by 2 plus constant c. Alright, so this is your answer for the b. And for the c, you have to integrate cosecant square. To integrate cosecant square, we have to think back. Is there any function we can differentiate and get cosecant square? Yes. You differentiate cotangent, you get cosecant. So meaning that you integrate cosecant square, you will get back cotangent. Cotangent 3x. And then you will ask yourself, is there any negative in front of it? Then recall back, when you differentiate cotangent, do you have negative cosecant? Yes. Any function which is start from c, okay, this is the way I remember. Any function which is start from c, when I differentiate, I definitely will get the negative, the answer, the negative. Alright, negative of my answer. Meaning that when I integrate, alright, if the negative is, when I differentiate cotangent, I got negative cosecant square. Now, when I integrate cosecant square, of course, negative still will be there, meaning that here should be a negative. And then I need to divide by the a, which is 3. A is the coefficient of the x, which is 3 for this case, and this is plus a constant c. For the example D, firstly, I will just take out the 2 first. Then I will focus on the function of trigo. Now, integrating secant square, okay, what do you get? Always recall back. Do you have any function you differentiate, you got secant square? Yes, there is a function, there is a tangent. When you differentiate tangent, you get secant square. Meaning that when you integrate secant square, you get your tangent. Tangent 2x. There is no negative here, okay, because when you differentiate tangent, you get positive secant square, right? So there is no negative. Then you can divide this by the 2. According to the formula, every time when you integrate a function, if the power here is not 1x, you need to divide by the a, the value of the a, which is 2 for this case, then plus constant c. Simplify the 2, you get the tangent 2x plus c. For the example E, you have 2 terms, integrating 2 trigo function. You will integrate it term by term. Integrate the first term, cosine x. Integrate cos, you get the you get sine x. And here is positive sine, according to the formula, minus the negative 2, I will just copy down first. Then I focus on integrating the sine x. Integrate sine, you get negative cos plus constant c. Then you simplify your answer, which you have a sine x plus 2 cos x plus c. Example F, I have 2 terms as similar to the question E. Firstly, to integrate the first term, just copy down the coefficient, that is 4. Then integrating sine, you have cos, cos 2x. And integrating sine, you have a negative cos. Means that you will have a negative cos 2x now. And don't forget to divide by 2, which is your coefficient of the x, plus 3 is just a coefficient, copy down again. Then integrate cos, you get sine. You get positive sine. And divided by the a is your 1 over 2, which is your coefficient of the x, plus constant c. Then finally, we need to simplify it. You have 2. Then first term, you will have negative 2 cos 2x plus, alright, over 1 over 2, meaning that you can bring the 2 up, multiply by the 3, you got 6. 6 sine 1 over 2x plus c. For the next video, I'm going to share you the integration of a trigo function by substitution method. Let's see you in my next video.